Oh, okay, so 50 people, 40 own a television, 21 own a computer, and 4 do not own either. Now, before we even read the questions, let's start to construct a Venn diagram for this situation. Need a big one. We put a box around it to signify that this box contains all the all the toys we're playing with, essentially. So the total number in here needs to be 50 because that's the number of people we surveyed. 40 of them own a television, 21 own a computer, 4 don't own either. Wait, why did I draw 3 circles? Yeah, so there's television and computer, and that's it. So 4 don't own either of them. That's one. Now, you notice that they never told you how many people own both of those things, right? They only told you 40 own televisions, 21 own computers, but not how many own both. So I can't just put a 40 here and 21 here because some of these 40 own a computer also, and some of these 21 own a television also. You see what I mean?
Mm-hmm.
So I can't just put 40 and 21 here. However, I can do some quick maths. I know that the television plus computer is 40 plus 21, right?
Yeah.
Oh no, sorry. That's what I just said is not true. So I know that, for example, if the total number of people that have a television is 40, then this must be 40 minus x, right? However many own both, that's x. So then the people that own just televisions are 40 minus x. Similarly, for computer, the people that own just a computer would be 21 minus x, right? And the thing is, all 4 of these things must add up to what? If I add
50.
all of 50, exactly. So I will say 40 minus x plus 21 minus x plus 4 equals 50, which means that I can solve this equation for x. First of all, plus x minus x cancels each other out, which leaves me with 40, 21, and 4, which is 65, and 1 minus x. Now, if I subtract the 50 on this side and add the x over there, I will get 65 minus 50 equals x, which means that 15 people own both a television and a computer. That is how you construct a Venn diagram. So normally, they will not tell you the both part. They'll tell you everything except the both part. And you'll have to do this kind of math to figure it out. Again, since I don't know the both part, I call it x. And since I know that 40 people own a television, I will say that the people that own just a television would be 40 minus that x. Similarly, the people that own just a computer would be 21 minus x. So let's fill it in. So 40 minus 15 is 25. 15 right there for both. And 21 minus 15 is 6, I think. And 4 people own neither. Just to check, if you want, you can add all of this up. It'll be 50. I trust my math, so I'm not going to check. You guys should definitely check though. Um, so what's the probability that a randomly picked person owns both a television and a computer? Remember, intersection means and means intersection. Okay? So we're talking about the common part between T and C. That's 15, isn't it? So 15 out of 50. Does this make sense?
Yeah.
Yeah.
Perfect. Owns a television, given that he also owns a computer. Probability that he owns a television, given that he owns a computer. Now, what does this mean? This means that I'm not talking about all 50 people anymore. I'm talking about only the people that fit to the given that part. So by saying given that the person owns a computer, I've basically done this. I told this group of people, everybody go home and sleep. Only the people who own computers come forward. Who will come forward? 15 plus 6 people. Everybody who owns a computer is now the only persons that are in my box right now. Okay? So how many of those people own a television also?
Is it 15 over
Yep.
6?
No, not 15 over 6. That would be more than 1, which is impossible. 15 over the total number of people in my box, which is all the computer people, which is 21. Okay?
Oh, okay, okay.
So again, given that computer means I'm only talking about the circle of computer, everything that is included in the computer now. I'm not talking about 50 people anymore. I'm talking about 21.
Oh,
And
Oh.
yeah, wow, that was nice to hear. And T means the people out of that circle that also own a television. So now, like, that's my only set. 15 is the part that owns a television, which means 15 over 21 is the answer. Does that make sense?
Mhm.
yeah.
Perfect. So Venn diagrams make life really, really easy for these questions. Uh, what? That this person owns both a television or that's not grammatically correct. Anyways, what they mean is television or computer. How do you say or in Venn diagram language? You say union. Union means or. And in terms of Venn diagram, do you guys know what union means? Like which numbers I need to count for union? In
No.
set notation. T union C means everything in T and C combined.
Okay.
Okay? And T intersection C means only the intersection between them. So this is T intersection C, and T union C would be everything in T and C combined. So 25 plus 15 plus 6 all over the total number of people, 50. I don't know what that is. That's like 46, I think. There. Okay?
Yeah.
Perfect. Then we have the person owns a television given that he does not own a computer. So probability that he owns a television given that not a computer. How do you say that? You say it like this. This little complement, we call it complement. It means not a computer. So everything except computers. Okay, first of all, now with this condition that I'm talking about people that do not own computers, what is my sample space now? It's not all 50 people, is it? How many people are in my sample space? If I'm talking about people that don't own a computer. What do you guys think?
So would it be just 25?
Isn't it 29?
29, exactly, because these four also don't own a computer. Like they're so broke
Oh,
they don't have either. So 29 people that don't own computers. Again, you can think about it easily like this. Before you were talking about computer, now you're talking about not computer, which means everything outside this orange circle or yellow circle. I'm colorblind. I don't know what that is. So that's 29 people. And how many people own televisions out of those 29 people?
Um, 40.
Out of 29 people, 40 people own televisions.
25.
25. There you go. What was that?
I
All right.
don't
So
know.
given that, sorry, that this person, by the way, Amy, does that make sense? Sorry, you went
yeah.
quiet. Yeah. And then for part E, we have that this person owns a computer, given that he does not own a television. So probability that he owns a computer, given that there is no television in his house. Okay. How many people are in my sample space now?
10.
10. And how many people fit my criteria of having a computer out of those 10 people?
6.
Exactly. That's the answer. And that's it. Venn
That's easy.
diagrams are easy. Well, yeah, I mean,
Each
when you
one.
look at it like this, it's easy. But I would say personally, the toughest part is building the Venn diagram. So just watch this video and, oh God, that's a horrible star. Watch this video and try to figure out, try to make sure you understand how I've done this. Because this method, ditto, every single time is the same thing. Okay?
Mhm.
Okay, so I'm gonna send you guys, I'm not gonna send it to you actually. On the website, if you go to this topic 4, look at probability 1 Venn diagrams. Or Venn hyphen tables. Okay.
Mhm.
From there, I want you to do a bunch of questions. I'll tell you which ones. Just a second. So can someone write this down and send it in the group too?
Yeah.
Yeah.
Okay. So question 1 is a very, very good one. Uh, question 1 and 2 also. Question 5, 6. 12 is nice. Okay, let's go to paper 2 questions now. Wait, we're 37?
7.
37.
37.
Are you guys one brain? You guys talk almost simultaneously.
Yeah, we are.
We hang out a lot.
All right, so question 41. 41. And yeah, that's pretty much it. Next class, we'll talk about two-way tables and then tree diagrams. That's another method of kind of portraying your sample space. Um, yeah, a bit tougher than Venn diagrams, I would say, but it's personal choice, I think. Anyways, that's about it for today.
Okay.